Today we are going to discuss about the heat transfer through fin. So fins are nothing but these are used to in automobile engines to give the effectiveness of cooling in the automobile systems. That is to exhaust the heat from the any engines or automobile system. So here we are finding the effectiveness of the given fin here. So this fin is made up of brass. For this we are finding the effectiveness and the efficiency of the given fin. Okay. Now this is the complete setup of the pin-fin apparatus, and in this case we are doing the effectiveness and efficiency identification using natural convection. Why again natural means this duct is open to air. So you can see this is open to air, that's why it is called natural convection. So pin-fin through natural convection. Now this is the fin which is made up of brass, which is having 12 mm diameter and 125 mm of length. Okay. Now for this again the thermocouples are being arranged. Total you have 5 thermocouples which are being attached on the fin to find out the temperature distribution along the different points. So these are the locations, and one is open to air, that is called the ambient temperature reading. So totally you will get T1 to T6 readings. In this T1 to T5 are the thermocouple readings, and the T6 is the open to air, that is the ambient temperature. We can take around 27 or 28 degrees centigrade. Now coming to the process, so you have to on the power button, and this is the variac or the thermostat which is used to vary the voltage. Now vary the voltage exactly, keep the voltage of 100 volts. Slowly this will go to the heater and this will give the heating to the fin. Okay, now this is the ammeter reading. So in order to find out the heat transfer rate, what you have to do, Q is nothing but voltage into amperes. Q is nothing but the heat transfer rate that gives the multiplication of the voltage with amperes. Q is equal to V into I. Now this comes the temperature reading, that is the thermocouple readings. So how many? Total we have 6 thermocouples. So this is the first reading T1, T2, T3, T4 and T5. So all the 5 readings will get from this thermocouple temperature readings, and the T6 will take the ambient temperature. Now after taking the readings, again you have to wait for 5 minutes. So after reaching the steady state conditions, again repeat the same experiment and take again all the 5 readings. Then once you confirm that the fin reached to the steady state temperature, then you take stop taking the readings and start doing the calculations. So you have to find out the efficiency as well as the effectiveness of the given fin by naturally. Okay, so this is the complete setup of the pin-fin apparatus. Thank you. So this is the continuation for the previous experiment, that is pin-fin through natural. Why natural means the duct is open natural to air, that's why it is called natural in the previous experiment. Now the same experiment we will do with forced, that means we are giving some external force, okay, on the fin, and we'll see what will be the efficiency as well as the effectiveness. Okay, how we are giving the some external agency means by using the blower. So this is the blower. So once you on the blower, you can see this sound. That means we are blowing some air, external agency on the fin, and we'll see what will be the efficiency as well as the effectiveness. Now what you'll do during the blower, when we switch on the blower, what happens, sometimes the voltage will be taken to the blower also. So if the voltage is varying, then what you have to do, you have to again adjust. Okay, always try to keep the voltage of 100 volts always. When the blower is on, some voltage is taken by the blower, that's why try to maintain the same consistent voltage during the experiment also. Okay, now what we are doing here, the same, we have to adjust to 100 volts using the thermostat, and you can observe the ammeter reading. Again the same 6 thermocouples are arranged on this fin. The 7th is the ambient temperature which is exposed to air. So the complete setup is same, but what is the main difference is what? We are giving some external agency, we are giving some air on the fin, and we'll just compare the efficiency as well as the effectiveness with natural as well as forced. Okay, now we'll start doing the experiment. Now after arranging the 100 volts, now this is the on button for the blower. We are onning the blower continuously, and we have to take all the 6 readings simultaneously. Don't stop the blower. Blower should continue until all the 6 readings are being taken. And one more thing is we have to identify that the voltage should not vary. The voltage should be always 100 though you are onning the blower. Now I'll start the experiment. I'm onning the blower. All the 6 readings, P1, P2, P3, P4, P5, P6. Now like this, you have to take all the 6 readings. Again the same condition until the steady state condition is reached. You have to take all the 6 readings with the blower on. Okay, so this is called the forced convection, and during this blower on you take the manometer reads. So this is the scale, you can observe, okay, the manometer reading. So this is the H1 H2 difference. So in the table column you can easily take the difference between these 2 readings, and you can calculate the efficiency as well as the effectiveness. Okay, so this is the main difference between the natural as well as the forced. In natural we are not using any external agency to the fin. Okay, but in case of forced convection, what we are doing, we are using a blower in order to blow air on the fin, and we will see the effectiveness as well as the efficiency. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.